My name is Kyle Niven, and this is my 2D CD nozzle simulation project. So we're going to start with in SolidWorks here, and we're going to create the actual CD nozzle here. So we're going to make a sketch on the front plane here. I'm going to start with a center line crossed. And I'm just going to get a good idea of the distance I want it. I've already made this before, so I'm just going to show you how I did it. Uh, so just going to create the rough outline here. Of what I want to do. And I've and I'm setting the actual diffuser to a specific size here. So I know exactly what the area ratio is. So this converging nozzle doesn't really matter what we do, at least in this simulation here. So looks a little different than the stuff I've done before, but it doesn't really matter as long as our diverging nozzle is within all the calculations that I made. So mirror this across and we'll get our actual CD nozzle. And there it is. So have the sketch all defined here. The one thing I need to do is go insert and insert a surface, make this planar, sketch, so ANSYS or Fluid will actually recognize this. So there's a rough design of the CD nozzle. So what I would have to do is save this as a IGES file. So just save it here as an IGES file. Like I said, I've already saved it here, but I would save that and then pull it up in Fluent here. So I'm not going to save that because I already have it, but that's what I pretty much did to make the nozzle. So we will move on to ANSYS. Switch screens. We're over here on ANSYS now. And here's easier for me. Right here. So now that we're in ANSYS, here we need to create a Fluent project here. Click Fluent, drag it over. We need to import a geometry. So have the IGE or IGS file here. Um, and you need to import it. But before you go any farther, I had to edit in Design Modeler just so it would actually see it. Let's bring it up. Switch my screen share to show the screen itself. Pull it up here, and once it comes in, there's a little lightning bolt next to the import. Just need to generate that, and it will actually generate the actual CD nozzle. So, won't need this anymore, so exit out of that. And I went to the mesh, step here, so need to just out of that. That first because I did not switch it to 2D because I do not want to do a 3D model on this. Closing here. I want to go over here while I'm selected on geometry. I want to switch it to 2D because that's the analysis we want to do. Now I can go back into the mesh. All right. Once we're in the mesh here, load, that's ready. There it is. Now it's ready. All right, need to define the walls and the inlet. So yeah, just click all the walls, right click, and create a name collection, all them walls. As long as I call them the right things, they will mesh correctly and get the right properties on them. This will be a pressure inlet. So we're defining it as a pressure. This will be a pressure outlet. Okay, so those are all defined. They're all in there. Go to mesh. We want to change the methods. So first select the geometry, hit apply. I'm going to do quadrilateral dominant here. It just works out better for what we're doing. And the last thing I want to change is the element size for this video. I'm going to do 0.002. Shouldn't take too long, but we shall see. And then we just generate the mesh. And we'll pause the video here to wait for it to mesh. We'll come back. All right, the mesh is finished. It took a little longer than I was hoping, but it's probably because I'm on videoing this. So the mesh is done. See, it's completely checked off. And then we just close this. While it's closing here, and we want to take this, right click this, hit update so it can update the mesh and load it into the project. All right, we got our green check that the mesh is in there. And then we will go into the setup. Set to verify it's a 2D dimension problem that we're doing. I want double precision. I'm going to push this to 2 solver processes. Done 3 and it does fine too, but 2 works for my computer at least. 3 is okay. So get that going. All right, looks like it's fully loaded here. A couple things I need to change right off the bat here. We're going to be doing a density-based solver. Make sure it's planar because we're doing a 2D space. Then I want to jump over to the models. I need to change it to include the energy equation. And I did change the viscous model to K epsilon, just something I'm more familiar with. So, and I missed the enhanced wall treatment. So, enhanced wall treatment there. So that is good. We are moving on here. Materials fluid is air, but there needs to be a change to this because we are not, or this is going to be compressible flow, so it needs to be ideal gas, which allows the density to change. Create and change that. All right, that's done. We're going to start with the isentropic flow. And with that, I need to define the inlet pressure. I did the same inlet pressure for both the isentropic and the normal shock, but so the initial pressure I put down was 200,000 pascals. I did some calculations to get a static pressure of 2,000, this number, just so I can type it in and not have to talk about it. Save one in there. All right, so that is the value I got. It was a half, Mach number is 0.5 coming into it. Thermal, I just chose the temperature to be 300. So then I applied to that. And close. And then I just need to define the outlet pressure. Once that comes up. Okay, so for the isentropic flow, had to drop this to 91,000 roughly after doing all the calculations to to make sure we had a supersonic Mach number at the edge or at the exit of the nozzle. It is negative because it is gauge pressure, and that had to be lower than atmospheric pressure. So there's that, and then the temperature after all the calculations dropped as well. So that was this value there. So, all right, I close that. All right, after all those properties are defined, and I went and initialized this. Let it initialize. Go to run the calculations. I did more iterations. I think on my project here, at least for this, but I'll do 500 and leave this one converged, but we shall see. So I will let this run, and this is running pretty slow right now, so I will pause the video again. Right, looks like it finished here, and it did converge about 448 iterations. So once we got that here, just needed to develop contours and some plots here. So I'll show the basics of that. Here, what I did. First off, change the name. One of them we had to do is velocity. And I had to change the contour to velocity magnitude across the entire thing. One thing I like to do myself is change the exponential to float because I think it looks better. I also, when putting it into the thing, I also change the dimensions just to have a bigger legend on it. So save and display. And there's our velocity plot. So, and went through and save those images just by clicking this down arrow, hitting this, and then saving it to a file, and then was able to move it over to the document that I made. So, um, but going through, did the same thing for, I won't create them all, but I'll show each one that I've got. So velocity, density, and all the same things. Just changing the contour name. Pressure, it's static pressure, and let's see, under properties is where I found speed of sound speed right there. And the last thing was Mach number. So just to verify we hit our supersonic Mach number, I will shoot this one. Is and coming out of the nozzle, we are at a supersonic Mach number, which is very close to what I calculated. So a little bit of difference, but that's just because I think of the geometry is not quite exact to it. But yeah, that's the contours. Went through, did all those contours, and put them into the Word document, and then created plots for each one of these here. So if I create a new plot, again, change the name to say velocity plot, had to add additional words to it because we can't have the same name. So again, just went through, chose velocity. This one, I actually have to create a new surface on this. So we want to create, we're doing this across the center line. So I had to create a new line, called it center line. We are starting because of where I put my geometry. I made the origin at the very front of the nozzle, right here. So the entire length of this is 60 centimeters. So that being said, when I was creating this, it's going to be right across the center line. So again, I put that center line in the middle of this, so I don't have to, or the origin at the middle of this, so I don't have to add any Y values, but since it is 60 centimeters, this is in meters, so 0.6, call it center line, create. And I just need to select just the center line here. And we've got all that. And the other thing I do is just something I like to do and change the Y from exponential to float. Just, again, looks better. So save and plot. And now we've got our, spin that off. We've got our velocity plot right across the center line. So, all right, and that looks right here. So again, went through, selected pressures, static, temperature too, missed that on the last one, but temperature is in there. Properties, all the same properties that I picked for the contours. We're gonna have all this, the plots themselves. Again, go to the velocity and the Mach number, and across the center line, save and plot that as well. And again, we hit our basically 2.63, 2.64. So it looks like as our max as we're exiting the nozzle. So that is for the isentropic flow through the entire nozzle. So your shocks are outside of the nozzle. And then what I did is I needed to do the normal shock in the nozzle. So what I did from there is exit out of this. Say, yes, I do want to close this. I do want to save that. Hit OK. Out. And instead of redoing everything, I just went and I duplicated this. That way it will keep the geometry, it'll keep the mesh, keep pretty much all the setup. And I just need to go and change my pressure because that's really the only, or my back pressure, that's really the only thing that changes out of this, back pressure and temperature. So again, upload it, go in here, do the new project. Again, double precision, two processes, still 2D. Let's load. All right, all done. Load it. Again, all the settings are the same. Density, just go to verify them. Energy on, viscous, K epsilon. All right, that's still good. Materials, back to the air. I'm gonna double check this, make sure we're still dealing with compressible flow. We are. And boundaries, double check are it's the same value as it should be. That's why I copied it, copied the project to make it easier. It is still all the same values. And this is what will be different here. So after doing the calculations, I calculated the back pressure for having the shock in the throat of the nozzle and the shock at the exit of the nozzle. And then I just literally chose a value somewhere in between here. Try to get it close to about halfway in between. So it ends up being a pressure, back pressure of this, and the temperature of this. I'm gonna play around with some numbers at times just to get this to look nice, but leave those with the numbers here. So we will go ahead and again initialize this. Let that initialize, and we are going to go into this, and we are going to calculate. Pause the video again. Completed the calculations. So again, it is the same exact thing as the other portion of this, but let's create the contours here. We'll start with the velocity contour. Actually, this time I will do pressure contour just to show. Not density contour, pressure contour. Again, cross everything. Center line's still in there because I saved it from the last one, but I don't want that right now. Again, I like to change this to float. This is 5. Doesn't really make a difference, but again, looks nicer. And we've got our pressure contour. As you can see, find the shock in the diverging part of the nozzle. Um, can start seeing some flow separation from the walls because of the viscous effect. So, and yeah, that's pressure. So again, went through, did all these. Again, we'll show the Mach number, so it's kind of the more important one right now. Make sure it goes subsonic. And as we can see, it goes subsonic after the shock, which is what was expected. So we do reach supersonic here before the shock, which is expected. Uh, Again, through the calculations, roughly about what I found for the maximum Mach number before the shock. Again, it's just a little bit off because the viscous effect on the calculations we do is not taking into account all frictions and other frictions. But yeah, that's the Mach number there, and gives a nice defined look of the slowdown of the air there too. So, but yeah, I did that for all the contours, and then again for the plots, went in, created a plot, and across the center line, it's already in there. Don't have to worry about it. So here is our pressure. And change my axes. Oh, it's still in there, so we're good. And save and plot. And we can see that we have a raise in pressure over the shock, which was expected. So there's that. Let's do the Mach number or velocity here just to see. And as we can see, it's opposite of the pressure, which is what is expected. But again, nice sharp drop right across the shock, and we've got that. And again, we'll look at the Mach number here, and it does the same sharp drop. So everything was to be expected, and everything was put into a Word document. And uh, thank you for your time.